Hello everyone, welcome again. This is the fourth and the final video of regression analysis. We were looking at the p-values of the independent variables. We see that the advertisement budget is significant. So it means the coefficient is 2.28. So on average, every let's say maybe just put $100 increase in advertisement budget is going to increase our sales by $2,284. That's the explanation. So for 1 unit increase in this value increases the sales by 2.28 units, but this is scaled by 100 and the sales is scaled by 1,000. And the north has lower sales than south. So on average, the north sales is about $2,530 less than the south sales. The reason for that is if the place is a north, that means we are going to multiply that by 1 times this coefficient. It's going to decrease our estimation. East has the highest sales, on average 2.54 times 1. West is lower than south, but it's not significant. That means west and south are, we could say that they have similar sales amounts. So if I want to make an estimation, for example, let's say, let me just open this area a couple of more rows, and say the advertisement budget north, east, and west. Let's just copy them and paste them somewhere here. And let's say we are going to estimate the estimated sales used for a specific franchisee location. And our budget, assume that we spent $500, so it's going to be 5. It may be a good idea just change it to $1,000, just put 10. And this place is located in the north, so 1 0 0, and our estimated sales is going to be equal to the intercept plus the advertisement budget times 10 plus north times 1. What we could do is we could just simply use a sum product function, and we can multiply these numbers, the coefficients, by these given values, and that takes care of the equation. And we are estimating that our sales is going to be 17,800. Okay, let's just use this times 1,000. So if my budget is 15, that sales increase up to 29.22. This is my estimated sales. If it is in the north, if it is in the south, then north is going to take a value of 0, east and west are going to take a value of 0, then the sales are going to increase up to $31,755. So this is our estimated sales, but we could have some kind of a prediction on our estimated sales, and our prediction is going to be, let's say, we will have maybe use an alpha, and just use an alpha 0.05, and then the confidence is going to be 1 minus alpha, so 95% confidence. And let's find our lower limit and upper limit on our estimated sales. So our lower limit is going to be the estimated sales minus we will use the the z-value for the alpha levels, or maybe we could just we have a very large sample size in there. So instead of maybe just using the z-value, we could just utilize the t-value as well, or you could simply just use, instead of using 1.96 for the alpha, you could just make a rough estimation and use 2 plus and minus 2 standard error above and below the estimated sales. So let's just ignore the alpha, just utilize the 2 as our z-value. So it is going to be the estimated sales and minus 2 times the standard error, and the standard error is 1.6, and upper limit is the estimated sales plus 2 times the standard error. Okay, so this is about 95% confidence. We're 95% confident that the estimated sales for a company, for a franchisee who has an advertisement budget of $1,500 and which is located in the South, is going to have the sales amount between $28,548 and $34,961. So if we see a franchisee which tells us that they spent, let's say, $2,500 and their revenue is $35,000, then we could say that our estimation tells us that the lower limit is 51. You are claiming a 35. It's either there's something wrong with your revenue reported revenue amount, or maybe the reported advertisement budget amount. So it may require some kind of an audit on this franchisee because of this difference. Okay, so this is everything that I am going to provide about regression analysis, and thanks for watching.